Hello student, in this part of tutorial we can prove the following mathematical expression using principle of mathematical induction. 1 times 1 the whole factorial plus 2 times 2 factorial plus 3 times 3 factorial plus n times n factorial is equals to n plus 1 the whole factorial minus 1 for n greater than 1. Now, this expression can be proved by using principle of mathematical inductions using the following steps. Since the given proposition is given here, now using the following step, that means step 1 is we need to start for n is equals to 2 because here n is restricted for n greater than 1. Now, for n is equals to 2, we have 1 times 1 factorial plus 2 times 2 factorial. So, 1 times 1 factorial plus 2 times 2 factorial is the same as 1 plus 4 because 1 factorial is 1, 2 factorial is 2, so 1 times 1 is 1, 2 times 2 is, which is 4, so 1 plus 4 is 5. And the right hand side here, for n is equals to 2, which is 2 plus 1 the whole factorial minus 1. 2 plus 1 is 3, 3 factorial is, which is the same as 6, then 6 minus 1. 6 minus 1 is 5, so 5 is equals to 5, which is true. The second step is assumption. Suppose that the given proposition is true for n is equals to k, means replacing n by k. Assume that it is true for n is equals to k. That is 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial plus k times k factorial is equals to k plus 1 the whole factorial minus 1. This is our assumptions. Step 3. We want to show that it is true for n is equals to k plus 1. Means we need to prove or we need to show that 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial plus k times k factorial plus k plus 1 times k plus 1 the whole factorial is equals to k plus 1 plus 1 plus 1. That means k plus 2 the whole factorial minus 1. So our claim is given in such a way. 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial plus k times k factorial plus k plus 1 times k plus 2 the whole factorial is equals to k plus 2 the whole factorial minus 1. To obtain such a result, let us start from the left hand side of our claim. That means 1 plus 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial plus k times k factorial plus k plus 1 times k plus 1 factorial. Dear students, these expressions from step 2, that means 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial plus k times k factorial from step 2. Here is the same as what? K plus 1 the whole factorial minus 1. So replace that expression by k plus 1 factorial minus 1. So this expression is replaced by this k plus 1 factorial minus 1. The other one is here we have k plus 1 times k plus 1 the whole factorial. Dear students, here we have k plus 1 factorial as a common. K plus 1 factorial, here also k plus 1 factorial. Take the common one, which is k plus 1 factorial. K plus 1 factorial, the whole into, we have here 1 plus here we left what? K plus 1 and here we left minus 1. So we have k plus 1 the whole factorial into 1 plus k plus 1 minus 1. This expression 1 plus k plus 1 is k plus 2. Implies that we have this is k plus 2, so k plus 2 times here k plus 1 factorial minus 1. K plus 2 times k plus 1 factorial minus 1. Dear students, this expression k plus 1 time k plus 2 time k plus 1 the whole factorial is equivalent with k plus 2 factorial, because k plus 2 the whole factorial is the same as k plus 2 time k plus 1 factorial, since we know that k factorial is the same as k into k minus 1 factorial. So using that expression k factorial is k into k minus 1 factorial, k plus 2 factorial becomes k plus 2 as it is times k plus 1 the whole factorial. As a result, the expression k plus 2 time k plus 1 the whole factorial minus 1 becomes what? K plus 2 factorial minus 1, due to k plus 2 factorial is the same as the k plus 2 times k plus 1 factorial. This is the required result. Thus, we can say that this is true for n is equals to k plus 1. Dear students, again, don't forget to subscribe, like, share, and comment this channel. And thank you. Thank you.